You are given the following function, f of x, which is equal to c times x plus d. We want to be able to find the derivative of the function using the definition of a derivative. So the definition of a derivative states the following. The derivative function, or f prime of x, is equal to the limit as h approaches 0 of f of x plus h minus f of x divided by h. So we're going to find a limit of that function, so we're going to get the limit as h approaches 0, and so x plus h is going to be the input now on that function. So we're going to get c times x plus h plus d, and then minus the function itself, which is cx plus d, and then we're going to divide that by h. Okay, so now let's go ahead and then distribute. So we get cx plus ch plus d. If we distribute the sign, we get negative cx, and then that's minus d divided by h. Okay, now what can we simplify to 0? We have cx and minus cx. We have plus d and minus d. So now we have the limit as h approaches 0 of ch over h, and then we can then simplify the h, and then what's left is the limit as h approaches 0 of the constant c, and therefore our answer is going to be c. So therefore that is the derivative of that function. Okay, now the next thing is we want to be able to find the domain of the original function. So the domain of the original function, f of x, is equal to cx plus d. And that means we can plug in any values of x, meaning all real numbers. So therefore the domain is either r or going from negative infinity to positive infinity. Okay, and then we want to state the domain of its derivative function. So we have f prime of x, and f prime of x gave us a constant c. So that means that if we wanted to graph wherever c was located on the graph, okay, that would be a horizontal graph, and that means that every value for x is going to correspond to one y value. So again, that means that this can be all real numbers, so the domain can be either negative infinity to positive infinity, or we can just say all real numbers.